Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X researcher and professional physicist, and today I'd like to share with you one of my articles on why Venus is so bright. Now, I wrote this article in March of this year, but I think it is still relevant because Venus continues to be much brighter than usual. Now, Venus is the second planet from the Sun in the solar system, and since Earth is the third planet from the Sun, Venus's orbit is right next to Earth's. Venus is also the planet that comes closest to Earth, as its orbit is closer to Earth's orbit than Mars' orbit, the fourth planet from the Sun. Now, it has been observed in recent months that Venus seems to be getting extremely bright. In fact, it is supposed to be getting brighter, as it is right now getting closer to the Earth, and this was in March, remember. Now, Venus will be at its closest distance to the Earth between March 25th and March 28th, 2017. Figure 1 shows a solar system scope view of the solar system on March 27, 2017, where it can be seen that Earth's and Venus's positions are very close. So here is Earth, and here is Venus. As you can see, they are in alignment. So if you look from Earth towards the Sun, Venus is right in line. Now, amateur astronomers from around the world are reporting that Venus is brighter than they have ever seen. Figure 2 shows the relative size of the Moon and Venus from a Steve Olson and R. Wayne Steiger video, showing that Venus is much larger than expected. In fact, Venus seems to be about half the size of the full Moon as indicated by the yellow line. And the yellow line has the same length as the diameter of Venus, as we can see here in the figure. Now, I believe this image is from January 24th. And so here we have the Moon, and this is Venus. And this yellow line is about the same diameter as Venus. And if you draw it close to the Moon, you see that it's only about half the size of the Moon. So now we're going to calculate how bright the Moon is actually supposed to be in comparison with Venus. And to do that, we need to calculate the brightness, which is the intensity. And the intensity is given by the power generated by the source per unit area. The source is, of course, the Sun. So P Sun here, so B Moon means the brightness of the Moon, would be the power generated by the Sun divided by the surface area of the sphere centered on the Sun and ending at the Moon. And we are assuming that the Moon is, of course, full, so it's on the opposite side to where on the opposite side of the Earth to where the Sun is. So this gives us 4 pi RES plus RME all squared. And but we can approximate this to just P Sun over 4 pi RES because the distance RME, which is the distance between the Moon and the Earth, or the orbital radius of the Moon, is only 0.26% of the Earth's orbital radius, or the distance RES between the Earth and the Sun. So this is very small in comparison with RES, so we can just drop it and make a small approximation. Then Venus's brightness is given by P Sun over 4 pi RVS, where R is the distance between Venus and the Sun, or the orbital radius of Venus. Then we can calculate the relative brightness of the Moon in relation to Venus, which is given by B Moon over P Venus, which is P Sun over 4 pi RES squared divided by P Sun over 4 pi RVS squared, and that translates into just RVS over RES squared. And remember, RVS is the distance between Venus and the Sun, and RES is the distance between the Earth and the Sun. Then, since Venus's orbital radius is 0.72 AU and the Earth's orbital radius is, of course, 1 AU, because this is in astronomical units, and 1 astronomical unit is the distance between the Earth and the Sun. Then equation 4, so the previous equation, would simply be, which is the ratio between the brightness of the Moon and the brightness of Venus, is simply 0.72 squared, which is 0.52. And this means that the moon is 52%. The moon's brightness is 52%. So the moon has 52% of Venus's brightness. Okay, but that doesn't take into account the distance between the two or how much they actually reflect. So to take that into account, we need to know that the moon reflects a maximum of 12% of the sunlight that falls on it, and Venus a maximum of 70% of that light. Thus, if the difference in reflective ability of both objects is taken into account, we get an equation for relative brightness. So there's a little r there with B moon, which stands for relative brightness. And we then have 0.12 over 0.70. So the 0.12 is the 12% that the moon reflects, and 0.70 is the 70% that Venus reflects, times RVS over RES squared, which is 0.52, and so we get 0.089. Now let us calculate the relative size of both objects. For this, we will use the angular width. The moon's angular width for an observer on Earth is given by the moon's diameter divided by the distance between the moon and the Earth. And that means that a moon, or angular width for moon, is 2 times the radius of the moon divided by the orbital radius of the moon, RME. And then we'll do the same thing with the angular width for Venus, but remember, this is for an observer on Earth. So we have twice the radius of Venus divided by RVE, which is the distance between Venus and the Earth. Then to get the moon size in relation to Venus's size, we take the angular width of the moon divided by Venus's angular width, and we have this equation then, 2rm over RME divided by 2RV over RVE, or RM over RV times RVE over RME. Then we can use the fact that the moon is 27% of the size of the Earth and Venus is 95% of the size of the Earth. So we can write that the radius of the moon is 0.27 times the radius of the Earth, and the radius of Venus is 0.95 times the radius of the Earth. And that will simplify that equation. Then we will use the fact that Venus's position, so this was the time when that photograph was taken, on January 24th, which is 52 days from March 27th, when Venus is at its closest position to Earth. Venus has an orbital period of 225 days, so this translates into an angle of 83.2 degrees of the orbit of Venus. And in radians, that's 1.45 radians. Then we have here a diagram which illustrates all the distances. This would be Venus's position on January 24th. This is Venus's position on March 27th, when it would be at its closest distance to Earth. Here's Earth. Here is the angle subtended by this arc length distance between the two positions, and that's 1.45 radians. Then we can calculate this distance S, which is an arc length, which is basically the radius times the angle in radians. So we have 1.08 times 10 to the 8 kilometers times 1.45 radians, which is 1.57 times 10 to the 8 kilometers. Then we actually need this distance from Venus directly to Earth, the straight line. And to calculate that, we approximate this to a right-angle triangle. And this then S becomes one side of the triangle. And this becomes the other side of the triangle. And then the distance we want is the hypotenuse, which we can obtain using Pythagoras. Now we know that the shortest distance between Venus and Earth is 3.8 times 10 to the 7 kilometers, which here we call RVE min. So that means that the distance between Venus and Earth is the square root of S squared plus RVE min squared, which is then 1.62 times 10 to the 8 kilometers. Then the relative size of the moon to Venus is given by this equation, Rm over Rv, Rve over Rme, and Rm we have written as 0.27 Re, and Rv as 0.95 Re. And then RVE we calculated is 1.68 times 10 to the 8 kilometers, and RME is 3.8 times 10 to the 5 kilometers. So we obtain 121. And that means that the moon will seem to be 121 times larger than Venus. And this is just in size. Now we actually want to look at the brightness. So if we want to take both brightness and size into account, we need to multiply equations 6 and 12. And equation 6 gave the relative brightness of the moon in relation to Venus. And we obtained this value, 0.089. And then A moon over A Venus is, of course, that value of 121. So we obtain 10.8, which is approximately 11. And that means that the moon is supposed to look 11 times larger than Venus if everything was normal. However, from the photograph we saw, we can see that the moon actually looks only about twice the size of Venus. And this indicates that Venus is much brighter than it should be, at least 5.5 times brighter than normal. Now, why would this be happening? Well, Venus is a bit different from the other rocky planets in the solar system, as it does not produce its own magnetic field and therefore its own magnetosphere. The magnetosphere is a bubble produced by a planet's magnetic field which deflects the charged particles in the sun's solar wind. However, Venus has an induced magnetosphere which is about 10 times smaller than the Earth's magnetosphere. And we can see here in this diagram what Venus's magnetosphere looks like. It's not produced by the planet itself, it's an induced magnetosphere. It's produced by the solar wind particles ionizing its own atmosphere. So it's actually produced by its own ionosphere. And it's much like a comet's magnetic field. Look how different it is from Earth's. Earth and Venus are about the same size. But Earth produces its own magnetic field, and as you can see closer to the planet, it's like a ball magnet's magnetic field, but further away, and you can see how far it spreads away from the planet, how fat it is compared with the size of Venus's induced magnetosphere. So on this side, the Earth's magnetosphere is compressed by the solar wind, so it looks shorter. And on this side, it is a long but thick tail. Whilst Venus's magnetosphere is very close to the planet itself, it looks like a comet's coma. And on this side, it has a thin tail. Now, the shape of Venus's induced is shaped like a comet's tail, right? And the name comet's tail is appropriate because a comet develops a tail and a coma in the same way as Venus's induced magnetosphere is produced, and that is through electric charge exchange between the solar wind and the comet, and in this case with the planet Venus. The fact that Venus does not produce its own magnetic field suggests that it does not have a hot liquid core inside it that conducts electricity like the Earth has. Venus has a very dense and hot atmosphere, and there are lots of craters on its surface that have not eroded and so look like they were recently created. Now, it is believed that craters are caused by asteroid impacts, but according to the electric theory of the universe, craters are caused by electric discharges between charged objects passing close to each other. Comets have been found to have lots of these craters as well. Venus also rotates about its axis in the opposite direction to most planets. This suggests that Venus might not be a natural solar system object, but rather a captured object. Since Venus has so many characteristics similar to comets, it is possible that Venus was at one time a comet that settled in a stable orbit within the solar system. Now, the fact that Venus is so much brighter than normal can be attributed to two possible factors. The first is that the ionization in Venus's ionosphere has greatly increased as a result of extra charged particles in the solar system due to the presence of extra stars such as, for instance, several brown dwarf stars. Now, this has happened to, or seems to be happening to, our planet as well. Our ionosphere is getting more and more ionized, and we are now seeing high altitude lightning, which is, I am almost certain, caused by what is happening with our ionosphere. It is, of course, to be expected because we can see that our magnetosphere is under impact, not just from the solar wind, but from other directions due to the other objects, these brown dwarf stars that have rejuvenated being in the inner solar system. Now, in the 1960s, microwave radiation emitted from Venus's ionosphere was detected, and it is possible that the increasing ionization in recent years has led to the emission of visible light as well. Venus has lightning, even though it does not have much water. The lightning has to be caused by electric discharges from the upper ionized atmosphere to the surface of the planet. And this again is basically what is happening on our planet as well. The second factor is that Venus's orbit may have been perturbed by an object passing close to it. Thus, it is possible that Venus's orbit is now a bit closer to Earth's than before, which would potentially cause Venus to come much closer to Earth than it usually does. Now, if Venus comes close to Earth so that the two atmospheres almost touch, its history as a possible comet makes this event very likely to be dangerous for our planet. It is not likely, though, that the planets would collide because planets will eventually repel each other once they equalize their potentials. But the potentials are equalized through electric discharges, and that would destroy much of the surface of the Earth, which would become littered with craters from the discharges, at least the part facing the planet at the time. In conclusion, something is definitely happening to Venus. The most likely cause is increasing ionization of its ionosphere due to the effect of the brown dwarf stars in the inner solar system having their own particle fluxes or stellar winds. It is possible as well that Venus is experiencing both an increased ionization of its ionosphere and a slightly perturbed orbit that may bring it a little closer to the Earth. I am Dr. Claudia Albers, Planet X physicist. Thank you for watching.